This is privacy-preserving AI agents, and super excited to be talking about the future of autonomous on-chain execution. Like I was mentioning you, right? Why do we need privacy-preserving AI agents in the first place? You have an AI agent, and then you have a trading strategy, whatever that is, whether there's an arbitrage or you see an AI agent that can buy a token index 1 and sell it index 2. When this is actually happening and you are able to automate this, because that's the whole point of AI agents, right? To execute transactions faster than humans can do. And honestly, I find quite fascinating AI agents of all the things that enable us, mainly because if you think about fundamentally, because we're able to automate all these things, now we have more times for ourselves. So that's great. But then the problem comes when you are automating a transaction or you're automating a trading strategy. And then, because we have all this public information, let's say that someone is going to be watching your AI agent that is executing this strategy. Because someone is going to be watching it, and let's say that N number of agents now are watching your strategy, and they will be executing it at the same time as your AI agent is executing it. There's basically no information asymmetry for this transaction to be executed. So now the trading strategy basically is nullified. So you want to prevent that from happening in order to have the benefits of having this trading strategy in the first place. So how can we achieve a privacy-preserving AI agents? If you combine Aztec network with Functor, now you will have fully autonomous privacy-preserving AI agents. So I want to introduce you Functor network in the first place. So Functor, fundamentally, it's a key store layer. If you haven't heard what a key store layer is, it's an infra that was actually proposed by Vitalik probably like a year ago. And what it is basically acts as a verifiable layer for authentication information of smart accounts. So think about it that your authentication information, right now you have your private keys, but this could be your passkey, this could be YubiKey or a combination of a threshold signature to access your smart account. So now a key store layer unifies how L2s access and verify authentication data in smart accounts. So you give authentication data, let's say interoperable superpowers. So Functor Network introduces a new primitive called maxims. So maxims are smart account session keys on steroids, because now session keys have interoperable capabilities that any L2 can access. And this is particularly important if you want to automate transactions with AI agents. So the traditional approach is that you have your private key, you will have to delegate your private key to this AI agent, or you probably use something as NPC. We're still doing off-chain computation. Instead of doing that and delegating your keys to the AI agent, you create something that we have, or we call an ephemeral private key that is interoperable, right? So you turn your private key into a maxim, which is, again, like I mentioned an interoperable ephemeral session key that has composable interoperable properties. Again, why? Because this session key lives in its own, let's say, L2 that any L2 can access to. You want to have a strategy that is in Optimism, in Polygon, and Aztec, and then they will actually verify if the authentication it's in Functor network, and then we'll say, it verifies cryptographically, and then you execute that transaction. So how would a transaction of an AI agent, a privacy-preserving transaction, will look with an AI agent? So the AI agent will be watching, let's say something similar as a limit order. It'd be watching the transactions through an oracle. It will sign the transaction on your behalf. It will generate a CK proof. Then you broadcast this to Aztec network. And this is the part that is fundamental, because now whatever the AI agent is executing will be completely private. And this is what gives the edge. And the problem that I was talking to you earlier is that now, because now it's basically everything encrypted, if you want to see it that way, now you're still able to have the edge in the information asymmetry in the first place. And then the transaction, it's settled. So I think the most fundamental part when you combine privacy and autonomy is that by enabling having privacy-preserving infrastructure, you're able to create trust across the transactions that we're doing on chain. And I think this is the most important part that our ecosystem needs. We need trust in order to have more adoption. And by achieving this through cryptography, we're able to have more adoption in our space. So this is I want to leave it to a lot of questions because there's a lot of things that could be done. We're actually excited to talk with builders that want to be combining Aztec Network with Functor to create multiple strategies with AI agents. So thank you very much, and I'll leave it up to questions.
Thanks for the talk. When you're saying that the privacy is coming into your trading strategy, doesn't privacy include a certain kind of latency into the trading strategy? So if you have, like, I agree with the premise you were mentioning, which is you create an agent which trades on Hyperliquid. Now the validator or other agents would start observing this agent if they see there is a profitable P&L. But as soon as you bring a privacy layer to your agent, the privacy actually compromises the latency aspect of your execution. So how do you keep things private but don't compromise on latency?
Yeah, but I mean, like I was mentioning at the beginning, right? But if you have an AI agent watching your strategy, and then you have a lot of agents watching that strategy, it nullifies the information asymmetry. So I'd rather add a bit of latency in order to make sure that I still have that information advantage, right? Does that make sense? Because you have a lot of AI agents watching that strategy, and because you don't have any computational latency, they're executing that strategy at the same time, right? So I'd rather add some latency to it, but I know that my transaction has the information asymmetry to benefit from that arbitrage. Does that make sense?
It does. And does that mean that when you're encapsulating your strategy in a privacy layer, that the validators are not going to be able to kind of, because what I'm concerned about, that even if you encapsulate your trading strategy in a privacy layer, how does the MEV coming from the validators prevent this strategy from being exploited?
Like if you're talking about like MEV attacks, for example,
Yeah.
or specifically, same thing, because it actually, all of these prevent sandwich attacks and MEV attacks in general, because it's already, you cannot able to see what's going on in that transaction at all. It's actually, I think AI agents in general is one of like the first attacks that we've seen when we were talking about this with other teams, and actually with the Aztec Network team. Is like, it's the first problems that you resolve using privacy preserving, especially with AI agents. I think it's a massive, massive problem that is attacked when you use that. So it's actually one of the problems that is solved.
Thank you.
Mm-hmm.
Hey, I'm just curious, could you go into a little bit more detail about how the privacy is achieved here in the stack?
Sure. So I think it's a very high level overview of how it is, because the intention here of what's happening is like, let's say that you have your transaction. Again, we're going to be talking about like a limit order, right? Just for the sake of this example. And you say, I want to buy ETH at a certain price in a certain DEX in a certain chain. And I want you to sell that in another DEX. So you will set up that transaction, pre-sign the transaction, you generate an ephemeral or a maxim, an ephemeral session key. And then when you meet what is needed, the parameters are met, then this is where the CK proof generation comes, because you need a verifiable key in order to sign the transaction in the keystore layer. Then that is going to be broadcast to the Aztec network. So it's happening on the Aztec network layer, and then the settlement of the transactions happened in Ethereum. So basically the transaction is not saying exactly where it's going to, so you still have that trading benefits, if that clarifies what I'm trying to communicate.
Kind of a basic question. Would this be compatible with most EVMs once 7702 is released?
Yeah,
Okay.
Absolutely.
So anything fully
Yeah.
EVM compliant will be there?
Correct. This is actually EVM first infra.
Okay. Now, do you have notice about whether or not any of the other non-specifically fully compatible EVMs would generally be able to use this?
Could you repeat that question?
There's some other ZK EVMs that are not fully compliant. And so I was wondering if 77 is only partially implemented, would this be available for them as well?
So I mean, the 77 is going to be allowing you to, upgrade your EOAs into smart accounts, right? So any EOA that is EVM compatible will be able to use maxims from Functor Network and ultimately do, transactions on Aztec Network. So your question is like, can you use other CK ones? Well, if they're EVM compatible, well, yes, yeah,
Okay.
correct. If you're doing the settlement in Ethereum, basically.
Hi there. Can
Jim.
you talk a bit more about if and how Functor is like specifically useful for AI agent trading versus like a manual human trader, or even like traditional algorithmic trading?
Oh, absolutely. I think that's the coolest part. So for example, when you are you have an AI agent that is going to be executing a transaction on you in the future, right? So this is an asynchronous transaction that hasn't happened. So you, in order to make that transaction a possibility, you have to delegate your private keys to that agent. That's inevitable. Or you can use NPC, which is an off-chain transaction, and you're still delegating that key to a third party in a way. So what Functor Network Keystore Layer does is that instead of delegating that private key to the agent, you generate an ephemeral session key, and that session key will have whatever parameters you want. A parameters will be I want you to only execute this transaction on this DEX with this specific token on this specific chain, and that's what the let's say ephemeral key will have. So cryptographically, you verify that information as the true statement, and then that's verified through the Keystore layer, and then you execute a transaction and you put it on Aztec Network, right? So you make sure that everything is encapsulated. So that's how the transaction it is. So whenever the parameters are met in the future, that's where the automation comes into play.
Yeah, I was wondering if you could also shed a bit more light on the tech stack that Functor is using, or how you are creating the Functor network, and how far you are down the roadmap. Are you already live, or what's already live and running?
Great question. So Keystore layers are fairly new infra. So because we're basically one of the first team, if not the first team actually building on top of a Keystore layer, there has been a lot of experimentation of how Keystore layers works. So in terms of what we have like internal beta with Functor Network. Functor Network is an L2, but it's a minimal one. We don't have basically everything that a complete CK-proof rollup has. We only optimize to store, again, the authentication information of users. So we have a verifiable key and the account information, and that's about it. We don't optimize for TVL. We don't optimize for assets to be stored in the Keystore layer. We only optimize to have signers. So the status of that is the first iteration was to do the contracts, the Keystore contracts on the L1. So that we actually did that experiment, and it's extremely expensive to rotate keys in the L1 directly. So that's why Vitalik proposes to actually be its own chain. So this is where we're at right now. In terms of like the roadmap, we do plan to be launching testnet in the next 6 months or so. So keep posted on social channels. It's very exciting. But what is exciting for us is to say, like, when you automate this transaction plus adding the Aztec aspect to it, can you actually have an edge to the transactions that you're doing on chain?
Curious, on the maxims, why did you have to create a new primitive?
So right now, smart accounts enable you to have session keys, right? That's already an infrastructure provided by smart accounts. So Keystore layers, by existing, you add two components, which is interoperability and composability. So that's the added benefits that Maxim has to session keys. So it's a session key on steroids with the components of interoperability and composability. So it's basically our new primitive called Maxims.
On the steps through for proof generation, where are those proofs actually being created, and what's the duration in terms of time?
So there are multiple proofs happening right now, especially with the Keystore layer. The Keystore layer basically is doing the proof of making the verifiable key that is stored in our network. So that's the network does the proof. That's why it exists. And then you have like the traditional prover part in the Keystore layer. So a Keystore layer is a minimal CK rollup in a way. So the proofs, we have the most important one for us is the one on the authentication part. And those proofs are the one that are proven by the network itself. Yeah.
But you guys would have my trading strategies because I'm giving you my strategies and then you're doing the proving. So I'm not
No,
proving
this
myself.
will have the trading part will be on ASIC.
Oh,
We only
okay.
just authenticate the part on. We only authenticate. We make sure that can we take the money out of this wallet? Yes, you can with this specific, points.
Okay, makes sense. Thanks.
Cool, awesome. Thank you very much, guys.